Hello everyone, welcome back to my channel Ali Share Chemistry Class for All. Today's topic is about Grignard reagent. All of you know Grignard reagent is one of the most important reagent in organic chemistry. So this is an organometallic reagents. There are so many organometallic reagents which are very useful for the synthesis of different kind of alcohol, aldehyde, ketones, acid, etc. It is therefore synthetically very important reagent. So I have decided these topics for today's class. It is a large topics, it's a vast topic. So I will complete these topics in 3 or 4 classes. Now today's class is only for the preparations of Grignard reagent and its applications for the preparations of alcohols. So first of all, you have to know what is the Grignard reagent. All of you know this. I know the Grignard reagents is known as alkyl or aryl magnesium halides. Alkyl or aryl magnesium halide is known as Grignard reagent. So what is this? Alkyl or aryl magnesium halides are called Grignard reagent. So it is represented by RMGX or ARMGX. R is an alkyl group or AR is an aryl group, and X is here. X is equal to chlorine, bromine, or iodine. So, in short, the alkyl or aryl magnesium halides are known as Grignard reagent. Now, the next question is how we can prepare this Grignard reagent. This is also very simple method and very effective also. When an alkyl halide is treated with magnesium in dry ether, we get an Grignard reagent. So, next question is how can we prepare the Grignard reagent? So, the preparation of Grignard reagents is important for us. So, preparation of Grignard reagent. So, the Grignard reagent is prepared. I have already told Grignard reagent is prepared from alkyl halide by the treatment with magnesium in dry ether. So, we can write it like this: RMgX when treated with Rx when treated with magnesium in dry ether. So this is the most important solvent for this for the preparation of Grignard reagent, and the solvent must be dry. If the solvent is not dry, there is some problems. I will discuss it. So Rx when treated with magnesium in dry ether, we will get RMgX. So what is the importance is dry ether? So if you will not use this dry ether, there is a problems. The problem is the Grignard reagents will decompose to alkane if some moisture is present in the solvents. So how it is formed? All of you know here the magnesium is an electropositive element. So in this compound, the Grignard reagent it becomes delta positive charge and the nearest carbon become the delta negative charge. So the carbon center will become here negative and it will act as a nucleophile as well as a base. So this center, so this is the important part of the Grignard reagent. So this center, this carbon center attached with magnesium metal become negatively charged and it can now act as a nucleophile and as well as a base. So if you use dry, if you are not use the dry solvent, so if moisture is present in the solvent, so the water molecules will react with Grignard reagent to form alkane, and that means the Grignard reagent become decomposes. RMgX react with water or any other protic solvent, says methanol, ethanol, it will form an alkane. RH plus MgOH. So to stop this decomposition of Grignard reagent, we have to always use the solvent dry ether. The solvent must be solvent must be dry, otherwise the Grignard reagent will be decomposed. So now we take some examples of Grignard reagent. Say you have to prepare methyl magnesium bromide CH3 Mg Br. So methyl magnesium bromide, we can go backward. So this, you cut this part, and the alkyl part will be CH3 methyl group, and you write it as methyl bromide. And when methyl bromide is treated with magnesium in dry ether, we get our target Grignard reagent CH3Mg Br. So this is the very simple method for the preparations of Grignard reagent. So you have to take the alkyl or aryl halide and then add magnesium in dry ether. We will get the Grignard reagent. Take some one examples and another examples of aryl magnesium halide. Say phenyl magnesium bromide. You have to prepare this Grignard reagent, phenyl magnesium bromide. This is known as phenyl magnesium bromide. So how can we prepare this? We have to start, just cut it from here. We have to start from bromobenzene and add magnesium in dry ether. We will get phenyl magnesium bromide MgBr. So the starting materials for the preparation of Grignard reagent is the corresponding alkyl halide, and the alkyl halide is also prepared from alcohol. So this is the very simple way to prepare the Grignard reagent. So all of you can prepare any type of Grignard reagent for your purpose. Now, why this Grignard reagent is very much important in the synthetic organic chemistry or the preparations of different type of molecules? I have already told the nature of these reagents. What is the nature of this reagent? The nature of this reagent, if you typically look here, R MgX. So here R becomes delta negative and magnesium becomes delta positive. As it is electropositive element, it will be delta positive, and it makes this attached carbon with magnesium is delta negative. So all of you know, if a center is negative or delta negative, it can donate it can act as a base or it can act as a nucleophile. So the Grignard reagent can act as a nucleophile, can act as a base. So the use of this Grignard reagent is also very sensitive for the preparations of different kind of compound, because either it can act as a nucleophile or it can act as a base. So now I'm going to move to the preparations or applications of this Grignard reagent for the preparations of different kind of alcohols. So now I'm going to the second part of the today's class, the applications for the preparations of alcohols by using the Grignard reagents. Now, alcohols are the compound in which OH group is present, that is hydroxyl group is present. The hydroxyl group is present with an carbon atom. So typically we can write three types of alcohol: primary, secondary and tertiary alcohol. So in primary alcohol, we can write the general formula as RCH2OH, secondary alcohol RCHROH, and tertiary alcohol RCRROH. I have decided here the secondary and tertiary alcohol with the same alkyl group. So it doesn't matter, the alkyl group may be different, it doesn't matter. But I have taken here the examples of alcohols with the same alkyl groups. So this is the primary alcohol, this carbon is primary, this carbon is secondary, and this carbon is tertiary. So sometimes you make make mistake to identify the alcohols as it is primary or secondary or tertiary. So it is a very simple way. You have to focus on that carbon in which the hydroxyl group is directly attached. Which carbon? Say this is primary carbon. The OH group is attached this carbon, and this carbon is primary. And if you see this carbon is secondary. And if you see this carbon, this is tertiary. So you have to always identify that carbon which is attached directly with the hydroxyl group. So it is very simple. This is the primary alcohol, this is the secondary alcohol, this is the tertiary alcohol. Now we are taking separately the preparations of three types of alcohols: primary, secondary, and tertiary. The first one, preparations of primary alcohols from Grignard. So if you see the primary alcohols is look like this RCH2H. This is the primary alcohols. So and the Grignard reagent you have know we have taken the Grignard reagent in generally RMGX. RMGX. So here R is delta negative and this is delta positive. And if you look, the primary alcohol here is R group is present. So this R groups is coming from the Grignard reagents. And this CH2OH group, we have to add this CH2OH group. So the source of this CH2OH group is the aldehyde, the formaldehyde. Aldehyde, only which aldehyde? The formaldehyde. Because if you take another aldehyde except formaldehyde, it will transfer into the secondary alcohols. So the two part. If you break this primary alcohols, this part is coming from Grignard reagent, and this part is coming from formaldehyde. Formaldehyde. So here, Grignard reagent is acting as a nucleophile, not as a base. It is acting as a nucleophile, and the reaction is proceed as nucleophilic additions reactions. So how can you prepare? Just I am writing two lines. When a Grignard reagent is treated with formaldehyde in dry ether, we will get a primary alcohol after acidifications. So to prepare any types of primary alcohols, you can use this method. You take a Grignard reagent and formaldehyde. I am going to take some examples. So the simplest primary alcohols is ethanols. So I am starting from ethanols. Say ethanols. This is the ethanol molecules. So according to our concept, we have to use Grignard reagent and formaldehyde. So we cut it the compound from here. This part is coming from formaldehyde, and this part is coming from Grignard reagent. So what will be the Grignard reagent? The Grignard reagent will be CH3MgBr or CH3MgI or CH3MgCl, doesn't matter. And this part is coming from formaldehyde, CH2 So you have already separate out this alcohol into the two fragment. One is Grignard reagent, another is formaldehyde. So the reactions will happen between this Grignard reagent and the formaldehyde. So the steps are: I am taking this Grignard reagent CH3MgBr plus formaldehyde in presence of dry ether. So what will happen here? So this is the negative center, this is the delta positive center. And all of you know the oxygen atom is more electronegative than carbon. So in carbon group generally it becomes delta negative and it becomes delta positive. So if you see, this carbon is electrophilic center. So this is electrophilic center and this is nucleophile. So this carbon will attract here. So you see this is delta positive and this is delta negative and pi bond is opening. So what is happening here? This CH3 group is attached with this CH2 group. That means we'll get CH3, CH2, O, it will become minus and is MgBr will attach here. So we'll get OMgBr. This is very simple way. Delta negative will attach to delta positive and this delta positive attaches this delta negative center. So we'll get the compound. We'll get our compound CH3 CH2 MgBr. So after acidifications, water or H3 plus, we'll get our desired alcohol CH3 CH2 OH. So we have to do these steps acidification because it is a salt, and if you use water or H3 plus, it becomes it will form an alcoholic compound. So the Grignard reagents is useful for the synthesis of any types of primary alcohol. We are taking one more examples. Say you have to prepare CH3 CH2 CH2 OH. This is propanol. So you apply your concept. So this part is coming from formaldehyde. So cut it out from here, and this part is coming from Grignard reagent. So what will be the Grignard reagent? The Grignard reagent will be CH3 CH2 MgBr, and this is formaldehyde. So it is very simple. Just do it. CH3 CH2 MgBr plus formaldehyde in presence of dry ether. This is the important. Always you have to indicate this solvent, the dry ether. Otherwise, the alkane or alkane will be formed. So this is the important part of this reactions. You have to always use the dry solvents. So what will form? So here you see this is carbon is delta negative. So I have already told before, the magnesium metal which is directly attached to the carbon will be delta negative, and this is delta positive, delta negative. So this delta negative center comes here. So this carbon will attach to this carbon atom. So how can you write it? CH3 start from here, CH3 CH2, and then this CH2 attached with this carbon atom. So it is also CH2 and it will become OMg here. And after acidification, we will get our desired alcohol, which is propanol. So this is the simple way to prepare propanols. Now I am taking some aromatic alcohols. Say, for examples, benzyl alcohols. All of you know this is known as benzyl alcohol, benzene, and CH2OH. This is benzyl alcohol. So same concept. Just cut this compound from here, and this is from here. So this part is coming from phenyl magnesium bromide PHMgBr, and this part is coming from CH2 double bond, because it is also a primary alcohols. So this alcohol is known as benzylic alcohol. Benzylic alcohol. So the process will be like this. You take this Grignard reagent, or you can start from bromobenzene, magnesium in dry ether. It will form Grignard reagent Mg Br, and take formaldehyde CH2 double bonded O, dry ether, will get PHOMgBr, OMgBr, and then add water or acidic water, it will form, sorry, it will form CH2OH. So I think all of you have already known, already clear these problems. How can you prepare the Grignard reagent? The primary alcohol from the Grignard reagent. So the starting material is a Grignard reagent, and the corresponding carbonyl compound is formaldehyde. Only formaldehyde. Except formaldehyde, we cannot take any other aldehyde or ketones, because if you take any other aldehyde, it will form secondary alcohol, or if you take ketone, it will form tertiary alcohols. We are discussing in later. So now moving to the preparations of secondary alcohol by using these Grignard reagents. Secondary alcohol. So in general, secondary alcohol can be written like this: R CH OH R. So this is the symmetrical alcohol. So I am discussing only symmetrical alcohol. It doesn't matter the alcohol is symmetrical or unsymmetrical. So we are taking the symmetrical alcohol. This center is 2-degree alcohol. So in the same way, we cut it a alkyl group from this compound. So cut it from here. So this will be coming from Grignard reagent RMgX, and the remaining part is, you can see carefully, RCHOH. That means here we have to do a double bond. So this part is coming from aldehyde, RCH double bond O, not ketone, aldehyde. So RMgX, and another carbonyl compound is aldehyde. So by reactions with the Grignard reagent, with an aldehyde, we can get our desired secondary alcohols. So the steps are MgX. We take aldehyde CH double bonded O. This is delta minus. This is delta plus. This is delta minus. Sorry. This is delta plus. This is delta minus. So what will happen here? In the similar way, this is the all steps are similar, like primary, secondary, and tertiary in every alcohol. So it is acting as a nucleophile. So this R minus will attach to this carbon. So this is become RCH R O MgX. So after acidifications, again we will get our desired desired secondary alcohols. R CH R O H. Okay, this is very simple methods for the preparations of secondary alcohols. So what we have to remember? We have to remember the secondary alcohol is prepared from Grignard reagent by using a Grignard reagent and an aldehyde. So you have to choose it carefully. Now we are moving to the tertiary alcohols. So if you see, in conceptually, in the beginning of this preparations, we have decided primary alcohols, where we have taken formaldehyde. So there is no alkyl group in this formaldehyde. That's why we get the primary alcohol. But if you, in the second part, we have taken aldehyde for the preparations of formaldehyde. Secondary alcohols. So here one alkyl group is introduced and one H is replaced. So this is useful for primary alcohol. This is useful for secondary alcohol. Now, according to the concept, you can say this H have to replace to prepare a tertiary alcohol. So the starting material from the carbonyl part will be a ketone for the preparation of 3-degree alcohols. 3-degree alcohols. So what will be the approach of us? So this I am writing the formula of a general 3-degree alcohol, which in a similar fashions I can take it. This part is coming from Grignard reagent and this part is coming from a carbonyl compound. So this is from RNGX and this is from RRC double bond O ketone, and this is Grignard reagent. So Grignard reagent, by using Grignard reagent we can prepare 3-degree alcohols. So what we have to do, we have to take ketone and the Grignard reagent for the synthetic purpose. So in the 3 alcohol, that is primary, secondary and tertiary, can be prepared by using Grignard reagents, just only varying the carbonyl compound. If you take formaldehyde, we will get primary alcohol. If you take aldehyde rather than formaldehyde, it will form secondary alcohols, and if you take ketone, it will form tertiary alcohols. Now I am taking few examples, and I will discuss that how can you prepare this alcohol by using Grignard reagent. So first one I am taking this example. Say for example PHCH CH3, symmetrical, unsymmetrical, doesn't matter. So this is a secondary alcohols. This is a secondary alcohols. All of you know secondary alcohols. How can you prepare? We can prepare the secondary alcohol by using a Grignard reagent and aldehyde rather than formaldehyde. So you can cut it out from here. One method, you can cut it out from here and separate it from here. So this part is from Grignard reagent PH Mg Br, and this part is from CH3CH double bond O. So this is acetaldehyde. So very simple method. Just go backward. So how can you prepare this? Just use PH Mg Br plus acetaldehyde CH3CH double bond O. So you see, this is the Grignard reagent. This become delta negative, this become delta positive, and this is delta positive, and this is delta negative. So this negative center comes to here, and this will open up. So what will happen? pH CH CH3 O Mg Br. Now after acidifications, we will get our desired alcohol pH CH OH CH3. So this is a very simple way to prepare any types of alcohols. Now I am taking another examples. This is the secondary alcohols. We can also prepare this alcohol this is the method number 1. Method number A, we can also prepare this, as it is unsymmetrical. We can also prepare this alcohol by using, we cut methyl group from here. So the Grignard reagent will be CH3 Mg Br, and the aldehyde will be PHCH double bond O. So by combination these two compound, methyl magnesium bromide and benzaldehyde, we can also prepare the desired secondary alcohols. Now I am moving to another examples. Say, we have to say tertiary butyl alcohols. Tertiary butyl alcohols, you can say this is the tertiary butyl alcohols. This is a symmetrical 3-degree alcohol, where the alkyl groups are CH3 and this carbon is 3-degree. So any group, you can, all 3 alkyl groups are same. So you can cut any group from here. So the Grignard reagent will be methyl magnesium bromide, and as it is 3-degree alcohol, so the carbonyl compound will be a ketone. So this is coming from methyl magnesium bromide plus CH3 C double bonded O CH3 acetone and methyl magnesium bromide. So by using this method, we can prepare the tertiary alcohol. So I am summarized this today's class. So the today's class is all about the preparations of Grignard reagents and its applications for the synthesis of, for the preparations of primary, secondary and tertiary alcohol. So how can you prepare this Grignard reagent? You can prepare any Grignard reagent from alkyl halide or aryl halide. Alkyl or aryl halides, when treated with magnesium in dry ether, that is RX or ARX, when treated with magnesium in dry ether, will get RMgX or ARMgX. So this is the Grignard reagent, and it has been very useful for the synthesis of different types of compounds. We have today's class we have discussed only three types of alcohol: primary, secondary, and tertiary. For primary alcohols, what we have to need? We have to need a Grignard reagent and formaldehyde, only formaldehyde from the carbonyl compounds. And for the secondary alcohols, we have to take Grignard reagent and aldehyde rather than formaldehyde. And for the tertiary alcohol, we have to take Grignard reagent and corresponding ketone. So this is the today's class. I think all of you have enjoyed this class. Just listen carefully, and if you have any doubt or any questions or any other suggestions, you may write in my comment box. Thank you everyone for your kind patience. Goodbye and see you in the next class.